Okay, in this example 4, we are given a triangle with each side being 6 centimeters, but each side got cut in half. So this half is 3 centimeters and this half 3 centimeters, and it's all the way around. We are supposed to find the area of one segment shaded in the red. So these 3 segments are the same, but I do apologize for my bad drawings. But know that all 3 segments are the same. And the area of the formula for the segment is the difference between the area of a sector and the area of a triangle. Well, let's just select either the top sector, the one on the left, or the one on the right. And we put it inside a circle. So let's just select the top one. So we select the top one and put it inside a circle. It's going to look something like, let's see. So this is the circle, and center is here. We're going to draw this. Well, this right here, the 2 radii, they are 3 centimeters. So they are these 2 halves right here. So this is 3 centimeter. This is 3 centimeter. The segment is right here. So that's a top segment from the top sector that we selected. Now we know that this formula right here can be rewritten as what? Well, let's see. Bring it down here. Well, the area of a segment is equal to the area of a sector, which is this central angle theta divided by 360 degrees, multiplied by pi, multiplied by the radius of the circle raised to the second power minus 1/2 times the base times the height of a triangle. This triangle is actually an equilateral triangle. It is an equilateral triangle because if this side is 3 centimeters and this side is 3 centimeters, of course the leftover has to be 3 centimeters. Now, that's usually the assumption that I like to make. However, because I want to be a little more careful, I want to go ahead and use the general formula for the area of any type of triangle, which is 1/2 times base times height. However, you guys are more than welcome to try to use the formula for the area of the equilateral triangle, which is square root of 3. Actually, I'm going to write it down here. So area of equilateral triangle, lateral triangle is equal to square root of 3 over 4 multiplied by the side square. And I think I'm going to attempt to use this one like after I use this one. So I'm going to see if I'm going to get the same answer, which I think I should get, but we'll see. So how do we figure out this central angle right here? Well, we can figure that out by recognizing the fact that this triangle right here is an equilateral triangle. So this side is 3, this side is 3, this side has to be 3. So by definition of equilateral triangle, I know that the 2 bottom angles have to be the same degree, which is 60. And this has to be 60 as well. So that's from the definition of equilateral triangle. Well, with all 3 degrees now known, I can go ahead and try to find the height of a triangle. And the height of a triangle is technically the apothem, drawn right there. And remember that the apothem connect the center and the base of a triangle. And the base and the apothem intersect each other perpendicularly. So that's a right angle right there. So hopefully you can see that kind of small. Looking at this triangle, to figure out the height, aka the apothem, we can select either the left half or the right half. So I'm going to go ahead and attempt to use the left half of this triangle. Drawing the left half of that triangle, it's going to look something like, maybe like this. This is the apothem in the green, and this is the right angle at the point of intersection. And this short leg here is half of the base of the triangle. Now going back to this figure, this degree here, 60 degree, is right here. If this is 60, this is 90, then by the triangle angle sum theorem, the leftover has to be 30 degrees. But then by the 30, 60, 90 triangle property, we know that opposite to 30 degrees is a short leg denoted by a variable x. Opposite to 60 degrees is a long leg denoted by the formula x times square root of 3. Opposite to 90 degrees is the hypotenuse, also known as the radius of the circle, denoted by the formula 2 times x. But then we know that the hypotenuse here is actually 3 centimeters because it's the radius of the circle. So we set 2x equal to 3. Divide both sides by 2 to solve for x. We know that x is equal to 3 over 2. So this equals to 3 over 2. And this is only half of the base of the triangle. Well, if this is half of the base of the triangle, then the entire base of the triangle has to be equal to the value of 1/2 multiplied by 2, which is equal to 3 centimeters. But hey, guess what? That goes back to what we said about this triangle being equilateral, right? Because earlier I said that if this side is 3, this side is 3, then this side, which is the base of the triangle, has to have the same value, 3. So that really proves it, right? Well, anyway, if x is 3 over 2, and the apothem is x times square root of 3, well, we know the apothem, which is also the height of a triangle, of this triangle right here, is going to be 3 over 2 times square root of 3 centimeters. And this is the height. Well, we know the radius of the circle, we know the height of a triangle, and we know the base of the triangle now. All we have to do is that we go back to this formula and we plug in everything we know. And of course, we know the central triangle is 60 degrees right here. The area of a segment, let's see, I'm going to rewrite the formula, equals to the area of a sector, which is central angle theta divided by 360, multiplied by pi, multiplied by the radius raised to the second power, minus 1/2 times the base of a triangle times the height of a triangle. So we know the central angle is 60 degrees. So we get 60 divided by 360, multiplied by pi, multiplied by the radius, which is 3 centimeters square, minus 1 over 2, times the base, which is 3 centimeters, times the height, which is 3 over 2, times square root of 3 centimeters. Well, from here, it's just a matter of algebra, simplifying. 60 over 360 is going to give you 1 over 6. 1 over 6 times 3 squared, which is 9. So 1 over 6 times 9, which is going to be 9 over 6 pi. Minus 1 times 3 times 3 times square root of 3 is going to be 9 square root of 3. Over 2 times 2, which is going to be 4. So really, if we simplify it even more, we can tell that 9 over 6 can be simplified out to 3 over 2 pi minus 9 square root of 3 over 4 centimeters square. So this is the area of one segment of this problem. But we have 3 segments together, so all we have to do is that to find the area of all segments, we take the value of each area of each, we take the value of the area of each segment, which is here, and we multiply that by how many segments we have, which is 3. So we take 3 multiply 3 square root of 2 pi minus 9 square root of 3 over 4, which is going to be equals to, let's see, 9 over 2 pi minus 27 times square root of 3 over 4 centimeters squared. So this is a total area of all 3 segments.